So this is a key for the first comprehensive review package for Algebra 1, and I'll just be working through and showing you how to do the problems. So we're asked to figure out what the pattern is for each of these. What we notice on this one is that linear, which is adding a constant difference, we see that we had 2 plus a row of 3 on figure 0. We've got 2 more rows of 3 on figure 2. We've got 3 more rows of 3 on figure 3. And therefore, figure 1, we would expect to have 1 more row of 3. And that makes this a linear pattern. We notice that we're adding 3 each time. That's our constant difference. And that we started at 5 for term figure 0. So our equation will be f of n is equal to 3n plus 5, or y equals 3x plus 5. Doesn't really matter. We're told it's a sequence. We normally use n for sequences. So the second pattern, what do we notice? We don't have a constant difference, but we notice that we do have a constant ratio. These appear to be multiplied by 3, multiplied by 3. So then 27 times 3 will be 81. We're given that we check, yes, 81 times 3 is 243, and 243 times 3 is 729. So we know that this is exponential. We have determined terms 3 and 5, and we know that it would be f of n is equal to term 0 times constant ratio to the power of n, or y equals 3 times 3 to the x. Either way works. Turning the page. Whoops, not flipping the packet, but turning the page. What we see here is we see a 1 by 1 square with 4 things around the corner. And we might not notice this when we're just looking at figure 1, but notice that we've got a 2 by 2 square, we've got a 3 by 3 square, which means that the nth term is going to be an n by n square in the middle with 4 square tiles making up the corners. I'll jump straight to the equation. F of n is equal to n squared plus 4. Going backwards, it says to sketch figure 4, but that would just be a 4 by 4 square with 4 tiles on the corners. And it doesn't say to sketch figure 0. This one's a little tricky because we've got a 0 by 0 square with 4 tiles on the corners. So figure 0 would actually look like that. That does tell us that figure 0, looking back on it, we know that figure 0 would be 4, and this is a quadratic relationship. So finally, we've got a tile pattern here. What do we notice? Well, that 3 seems to be the same every time. There's 1 on top, 1 on the left and right, and it looks like this, in fact, both rows of 3 are staying the same every time, but that we're adding 1 to each corner, left, right, top. And so figure 0, we would expect to just be this block of 6, and we would expect this to be a linear pattern where we were adding 3 each time. So this is linear. We've sketched figure 0, and my equation f of n equals term 0 plus 3n. And doesn't matter what order you write this in. It could be 3n plus 6 or 6 plus 3n, either way. Okay. We've got another tile pattern here. What do we notice? Well, this one's a little bit trickier, but I notice that this is 2 by 2. This is 3 by 3. This is 4 by 4. which means that figure 0 should be 1 by 1 and then have this little plus 1 up in the corner that never changes. And this appears to be some kind of quadratic because I have a square. The question is, what happens when I get to figure n? Well, what I notice is that this square is always 1 bigger than n. When n is 1, square is 2, n is 2, square is 3, n is 3, square is 4. It's always just 1 bigger than n plus 1 in the corner, which means that my equation will be n plus 1 squared plus 1. And then finally, we've got a sequence here that if we analyze it, again, remember, always start with linear. We're taking away 6, taking away 6, taking away 6, which means that term 5 will be 6, term 0 will be 36. This is a linear relationship. 0 value is 36 and minus 6 times n. Just a reminder that for linear, it's term 0 plus constant difference times n, and for exponential, it is term 0 times constant ratio to the power of n. Also, mx plus b, or b plus mx, and ab to the x. So power for exponential multiplied for linear. All right, let's turn to the next page. And we have a different kind of problem. We are solving one variable equations. So I'm going to draw my line on my equals and start undoing things. I'm going to subtract 3. 2x equals 92. I'm going to divide by 2. X equals 46. I'll circle my answer. Next one, draw my line on my equals. I'm going to subtract 5, and I get negative 4x equals negative 68. Divide by negative 4, divide by negative 4, and I get that x is equal to 17. Circle my answer. And we'll just keep popping through them. This one's a little trickier, except that we know that the opposite of divided is multiplied, so I'm going to multiply by 3 to get rid of that. Boom, no fraction. I'm happy. X minus 7 equals negative 9. Add 7 to both sides. X equals negative 2. Circle my answer. Now, a couple ways I could do this one. I'm going to do this 2 different ways, once in D and once in F. This time I'm going to divide by 2, just because the opposite of multiplied is divide, and I've got x minus 8 equals negative 10. Add 8 to both sides, and I get x equals negative 2. Circle my answer. I'm going to jump down to F, and then I'll come back and do E, because while I'm on it, notice that I'm multiplying this parentheses by 2, which means that I could write it as 2x plus 10. 2 of each thing in the parentheses equals, now over here I might as well combine like terms. I've got 3 x's and an 8. Now it's just straight up solving. I'm going to subtract 2 x's from both sides. I've got 10 equals x plus 8. I'm going to subtract 8 from both sides, and I've got x equals 2. Doesn't matter what order I write it in, so I'll write it in standard form, which is normally the variable equals the number. And finally, let's just do this last one. We will subtract 5x from both sides. We get negative 2 equals 2x plus 8. Subtract 8 from both sides. We get negative 10 equals 2x. Divide by 2. And we get x equals negative 5. So that's solving one variable equations. Literal solving is the exact same thing, but there are just fewer numbers and more letters. So if we look at this, I want to get d by itself. I need to get rid of a divided by t. I'm going to multiply both sides by t. Those reduce, and I get d is equal to t times v. So d is equal to t times v. Over here, I want to solve for v, so I need to get v out of the denominator. I'm going to multiply both sides by v. Those reduce. And I've got v times d is equal to m, but I want v by itself. I'm going to divide by d, and I get v is equal to m divided by d. Solving for x, so I need to first get rid of that b, which is hanging out there. We'll get y minus b is equal to m times x. We divide by m, this reduces, and I get that x is equal to y minus b in the numerator of this fraction divided by m. And finally, a fairly simple one, I want b by itself. I just need to get rid of that h. Opposite of multiply is divide. B is equal to a divided by h. All right, turning the page. We are at 1104. We're going equation to table to graph. So first thing we need to do is, well, I mean, we could do anything we want first. Why don't we just go ahead and graph this one? We know that it starts at 3. That's the y-intercept. When x is equal to 0, I might as well put a 3 in while I'm there. It is going down 2 over 1, down 2 over 1, down 2 over 1. And if it's going down 2, that means that this is at 1, this is at negative 1, this is at negative 3. But of course, that means it's going up 2 in the opposite direction. So I've got 5, 7, 9. In order to graph, I only need 3 points. I like 3. I mean, theoretically, I only need 2, but I like 3 just to make sure I didn't make a mistake. There's my graph. So, g of x, exponential, starts at 1.5. 1.5 when it's 0, so we'll put in a 1.5 right there. Now, we're going to be multiplying by 2 every time, so I'm going to do some quick multiplication. This is going to be 3, this is going to be 4.5, and this is going to be 9. Did I do that right? I did not do that right. Why did I say 3 times 2 was 4.5? That's just silly. 6 and 12, of course. Hopefully you were shouting at the screen saying, Mr. Armerding, Mr. Armerding. So we're multiplying by 2 in this direction, which means dividing by 2 in this direction. 0.75, 0.375, 0.1875. So let's plot a few of these points. We can plot 3, we can plot 6, we can't plot 12, but that's good enough. Over here, we can plot 0.75 approximately, we can plot 0.375 approximately, and we know that this graph is going to look like this, and it's just going to keep going. Notice doesn't touch 0, just keeps getting smaller and smaller and smaller. All right, flipping over to the next page, we're still on graphing and equations. So we want to be a little bit careful here. When we're putting a negative into this, we want to make sure we put it in parentheses. I'm going to go ahead and start at 0 and find that y-intercept. When x is 0, I am at negative 7, so I can put that right there. And now I'm just going to have to do some calculations. 1 squared plus 9 times 1 minus 7, that's 3. Is that right? 1, 10 minus 7 is 3, so we're at 3 right here. 2 squared plus 9 times 2 minus 7, that's 4 plus 18 is 22, minus 7 is 15. So we're not going to be able to get these on the graph, but we are showing that we know how to actually calculate these. So this will be 29. Well, let's work backwards. We'll do a couple of them. Negative 1 squared. Notice how now this parentheses becomes important because negative 1 squared is negative 1 times negative 1. If you type negative 1 squared into your calculator, you will get negative 1 because order of operations says do the squared multiplied by negative 1. But we know that negative 1 times itself is equal to positive 1. So for -1, we get -15. For -2, we get -21. And for -3, we get -25. Notice that we never really get over to the other half of the parentheses, but if we keep going, we've got symmetry here and, excuse me, here, and our parabola will end up looking something like this. Not the greatest example for the purposes of this worksheet, but there we go. All right, and finally, at time 1536, we're going to work backwards. We've got an equation, excuse me, we've got a graph, we want an equation, we want a table, so we need to find two pieces of information. We need the y-intercept and we need the slope. Well, the y-intercept is right there at +1/2. To find the slope, I'm going to draw a slope triangle. I see two grid points here and here, so that will work for me. I'm going to draw my slope triangle. It looks to me like this is +2 in the change in y direction, and this is +4 in the change in x direction. I know that slope is change in y over change in x. Remember, rise over run. And that's 2/4, which is also 1/2, which means that my equation is y equals 1/2 x plus 1/2 mx plus b. So now we can use that equation to plug in some values. We know we started at 1/2, and we are going up by 1/2, so that's going to be 1, 3/2, 2, and going down, that's going to be 0, -1/2, -1. And we are done with this review packet. All right, I hope this helps.